our second session. So we are going to have Professor Kostas Eftimiou, Associate Professor at the University of Central Florida in USA. He's going to talk about assessment of the effect of service learning in introductory physics on students' learning and critical thinking. So please welcome.
Thanks. I'm sorry. Okay. Good morning. First, perhaps I should say that this is a talk I give in behalf of one of my colleagues. I'm not really the person behind it. I collaborate with the person who actually does the project. I should say actually that that's Elena Plitiani from our university, but it so happened that I come to Greece every summer, and she asked me if I can actually present this work to you. So, although I know what's happening with this course and I have collaborated with her in several projects, this is not really my project. So I'm not going to be a good sales representative for it. I can actually make some comments, I can present some of the ideas, but again, I'm not as enthusiastic as I should be, right? As I would have presented my projects. Okay, so you should take that into account, because I don't want basically to do a poor job and you to think that that's probably not as good work. In any case, the other thing I should tell you is that in the US, as probably you already know, activity-based courses is a big thing. So every university is trying to move towards physics education. This area is getting bigger and bigger and bigger. Every university now has a physics education group. In the same way, we have high energy groups, condensed matter groups, and so on. And those groups appear to grow actually as time goes, and it appears that there is more and more money, because that, our physics education in general is something that the public understands, and educators are willing to put more money. So physics education has a lot of momentum, and although sometimes the people who are traditional do not necessarily like physics education, the area is growing. So there are more and more projects that are happening along those lines. In any case, again, this is a project that has to do with physics learning. Our university is actually a huge university. We are the second biggest university in the US. We have 65,000 students. Okay. By any standards, that's a really big number. Obviously, those are not necessarily physics students. Physics, the number of physics students is actually small compared to this number. But we are really, really a big university. We are actually a town within a big town. We are located in Orlando, and we are really huge. And we are growing. We keep growing. Our president decided that probably we should not grow anymore, but we are going to see, because we have heard that again. So we have an introductory physics course. The number is not important. This is the number 2048. It's in a sequence really. It's physics 1. This is the physics 1, which is mechanics. And then there is the second part, which is electricity, magnetism, and optics. And of course, there is the third project. So those courses have several thousand of students every semester. So those are really big courses, because we serve a huge number of students. Not all 65,000 in our university, but certainly a huge number of the science majors. So, probably most of you know that students are not really happy to take this class. Okay, our introductory physics course is a requirement for many majors, including biology, but the students don't really want to take it. They don't really understand the value. So we need to find ways to make them more active in the course and to make them happier. And that's why we incorporate all those new ideas. So the service learning idea, service learning actually is more, service learning is more general. You can actually find many ideas that have to do with service learning. But Elena Feliciani in particular decided to apply the relation of the course to car accidents. And Orlando is one area where actually, which looks like Athens really. There are a lot of traffic. There is a lot of traffic. There are a lot of accidents, and in particular in the university, the students cross the roads in front of their cars. They don't really respect traffic lights or signs, and there are many problems. So Elena decided to ask the students to relate the course to traffic and in particular accidents. Okay, so that was the idea, in order to make them understand how the abstract physics laws relate to what they learn, what happens in society. Here, there are some objectives, as in every course. You can actually see them. Of course, the objectives and the goals in every course do not really change. I will read them. We'd like actually, or she would like to integrate the theory, the problem solving, and the experiments. That means activity-based ideas, things that the students do with their hands in the course. She would like actually to optimize the engagement of the students, because when you actually do the lecture, the students stay passive, and they actually these days they have their cell phones, they check mail, they check the web, they look at YouTube, and they don't really do anything. If you give them activities, then the students have to do something else, and they have to focus actually on the material you are asking them to do. And the other thing is actually you can integrate technology, which students like, and you can integrate exactly the technology they like with the course. So, when it comes down to service learning, that's that's a term, but the idea is the students have to learn by actually doing things. Okay, so when they take the abstract ideas, they apply to something in society, they have to think back, and then out of that evaluation, they got to learn more theory. So I don't really, again, that's actually where because it's not my project, it's actually here is where I don't necessarily present as well as I should. So what the instructor asks the students is actually after they have understood the theory, to go around the campus and apply the ideas. And actually they can find real traffic accidents and apply the physics, or they can actually create fake accidents, mock accident or something like that. Okay. So here is some side ideas about the course descriptions. Probably this slide should be earlier in the presentation. The course is a standard course. It's 3 hours, 3 hours lectures plus the traditional lab. And in the service learning component, there is this integration of the activity-based with the lecture. So it's not necessarily the real, the original idea. It's not. The lab is not separated from the lectures. So what happens really in the lab is small activities where the students have to do, and those activities have to be prepared based on the ideas that the instructor covered in the lecture. The instructor has named those activities mini studios. I don't think that's important, but in any case, it's actually small activities that happen in the lab, and the students learn by actually doing those activities. They learn to relate the theory to real time, to actual things they see in society. Again, there is many, if you have any experience with activity-based courses, all those ideas are still valid. Okay, there is nothing that that has been changed in this course. Everything that happens in any activity-based course is really it really applies here. So. I'm trying actually to simplify some things. So you can, the students see everything that happens in theory in action. As I said, they deepen their understanding of the theory. They strengthen their critical skills. They become more confident. There is a slide where there is. You can actually see how the confidence levels go up. They actually think about the career paths, because when the students take this course, they do not really understand how to apply physics ideas in real life. And of course now, after they see the application, they actually start thinking again. And some of them actually take a leadership role, and they actually learn how to lead the group. So the projects usually are done in groups of 3 to 4 students, and they collaborate. Eventually they write a report, and they present the report in front of all the students and other visitors. The visitors may be faculty, may be other people who would like actually to see those presentations. Also, the students present their projects in other venues, like in the dorms, or there is an open house for the department where high school students are coming, and they learn basically about the department and how you can use physics. So this slide, again, it may not be very revealing. It's actually one particular project that the students did. It has the inclined plane, which it's a standard problem for Physics 1, and they applied actually to traffic accidents when the slope of the hill was different. So obviously from the slide you cannot really say much, but the students actually did a lot of work based on simple physics. Okay, they went out, they measured slopes for the streets, and then they studied what is the effect in the accidents. This is the form that Elena has used to evaluate the projects. She invites actually a group of people to hear the presentations, talk to the students, and the evaluators assign some, not grade, but they assign some ranking, and you can actually see some, how the students are evaluated. Of course, those are not necessarily all the areas that the evaluators use. They may add additional comments regarding the knowledge of the students. Besides the form that you saw, there are standard tests, pre and post tests in physics education that evaluate students' knowledge. The force inventory test is a standard one that physicists are using. It's also used in this course to evaluate the student's knowledge. You can actually see one of the questions here. It's an easy question, but amazingly, a lot of our students who take physics answer it incorrectly at the beginning, and a lot of them answer it incorrectly even later. And that's one of the questions. There are even more. You can actually see some of the responses here. One is the pre-test and the other is the post-test after the students have done the projects and they have finished the course. You can actually see, as you expect, that the results after in the post-test are higher. And the second histogram shows to you the confidence level. Okay? You can actually see here how if the students are confident when they answer the question. And the confidence can go up or down depending on what they have learned. So again, the yellow is the post-test. In fact, here you can actually see for confident it has gone down a little, but very confident has gone up dramatically. So here is another question. The questions are not really important. The results are obviously the more important. Here is again the pre and post test. Here are the answers, how the students did, and this is the confidence level. So another question, again, not really important. You can actually see the confidence level. Another question, again, same idea, the confidence level goes up. So again, the idea here is to use some activity-based project in order the students to learn and engage. According to the results that my collaborator has taken, she sees actually there is a much better understanding by the end of the course. There is much more engagement, and the students connect better to the course. They actually understand the material better. And not only that, but their attitude towards the course changes. Once they see that the course is useful for something that has to do with everyday life, their entire attitude basically changes, and they see physics and the remaining courses in the sequence with a better attitude. Anyway, that's all I wanted to say. Again, I apologize to Elena for not being the best salesman for that. Again, it is not my project, but I hope that you got an idea. If you'd like to learn more, obviously I can connect you with the person who actually does the project. We are doing many more projects. That's actually one of the activity-based projects we do at the university. So there's much more to say. But in any case, thanks a lot.
Thank you.